This video simulates the arithmetic and logic unit of the Scott CPU. It is the simulation part of the 6th video of the How Computers Work Building Scott CPU YouTube playlist. We used Circuit Verse Simulator and the circuit is available in the link I leave in the description. So before to see ALU examples, we see what is bus 1. Bus 1 is this element is composed by 7 AND gates and 1 OR gate and a NOT gate, and if this input bus 1 is at 1, the output is the number 1. If this input is at 0, the output is equal to the input. So the input byte passes unchanged through the output. So this is a quick way to put a 1 in one of the inputs of the ALU. We need this because this is useful, and this is useful because every step we need to perform an addition, because we need to increment the instruction address register by 1 every step. And this is a quick way to put a 1 in the B byte, and by putting in the A byte the instruction address register, we increment by 1 the other operator in the ALU. So in this way we calculate the address of the next instruction starting from the current instruction using the adder of the ALU. So here you can see a circuit to simulate the ALU working, and here you see the ALU. Here is the A byte connected directly to the bus. Here the B byte connected to the bus 1 and to this 8-bit register that is called TMP. So it's a temporary register we need to acquire the first byte in input of the ALU, and to free the bus in order to receive the second byte for the ALU input. This is another register called accumulator, and it is in the output of the ALU, and we need it because we want to temporarily acquire and store the result of the ALU operation. These two are two registers, and this is a way to read what there is in the bus, and this other element is just an enabler we use to put the byte into the two registers. So let's see some examples now. So let's see the addition. We want to add the number 1 to the number 3 and put the result in the register R0. So for example, let's see what there is inside these two registers. So we click enable here and we put the byte on the bus, and we see all the bits are at 1. So R0 has all the bits at 1. R1 as well has all the bits at 1. So we want to put, now let's free the bus, we want to put the number 1 to the bus R0 and the number 3 to the bus R1 and add these two numbers. So here is the number 1. We put the byte on the bus, we acquire this byte from the register R0, so select, we free the bus. Now the number 1 should be in the register R0. Let's see, and you see the number 1. Now the number 3, we put the number 3 on the bus and we acquire it from R1. So R1 acquire number 3 with the set input. So now the byte is acquired inside the register R1 and we free the bus. Let's see if the number 3 is inside the register R1, and yes. Now we want to add the content of these two registers. So we put on the bus the content of the register R1 and we acquire it in the temporary register. In this way, we leave the bus 0 to 0 because we want to use the byte in this register, and we free the bus. Then we put the other byte on the bus. We choose the 000 code here, which is the other operation, and here in the output, because this is a combinational circuit, so as soon as the bytes arrive, the output is calculated. So here in the output there is the result, and we acquire this result in the accumulator with the set. So now I can free the bus. So here in this accumulator there is the result of our addition, and we put this result in the register R0. So we put the byte on the bus. We see is here in the accumulator there is the number 4. We acquire it in R0 and we free the bus. So in R0, let's see, enable, there is the number 4, and we performed an addition. Another simulation we can do is increment by 1 the content of the register R0. So let's see what there is inside R0. We put the byte on the bus, and inside R0 there is stored the number 4. So we leave this byte on the bus, and we put at 1 the bus 1, so, and we leave, and we choose the header operation, so 000. So here we have incremented by 1 the A byte. So at the output of the ALU there is byte A incremented by 1. We acquire it inside the accumulator and we free the bus. And now we store this result inside R0. So we put the byte on the bus from the accumulator, and we store it in R0 with the set input. So now we free the bus, and here let's see what there is inside R0 now, and there is the number 5. Please leave me a comment, let me know if you liked this video. Make sure you put a thumb up, click the notification bell and subscribe to my channel.